This is Britt Caswell with another example video. In this video I'm covering example 3 from section 1-5 in the SavvasRealize Algebra 1 textbook. We are looking at understanding inequalities with infinitely many or no solutions. So I start this out the same way that I would start with any equation. Alright, I'm going to put my river and I want to get everything with a variable on one side and everything without a variable to the other side. So my first thing is, before I shift anything around, I want to get rid of my grouping symbols. So I'm going to take this -3 and distribute it across that set of parentheses. So -3 times 2x is -6x, and -3 times -5 is a +15. And I have that is greater than -6x plus 9. Alright, so now my next goal is to move everything without an x to the left-hand side. So this -6x that's on the right-hand side needs to get over to the other side. So I'm going to add 6x to the other side of the equal sign. Now if I check that out, here the x's cancel out, leaving me with 15. I have greater than, these x's cancel out, 9. It's a little strange, isn't it? All my x's are gone. So in this case, it doesn't really matter what number I plug in for x. It's just going to disappear anyway. Okay, I could pick 0. I could pick 45,000. I could pick 11. It doesn't matter. So what we have to look at is this resulting inequality. And we have to ask ourselves, is 15 greater than 9? Well, yes it is. 15 is a bigger number than 9 is. So no matter what I choose for x, I get an inequality that is true. So what we say here is that there are infinitely, if I could spell infinitely, good lord, infinitely, maybe, I think there's an E in there, many solutions. Okay, so on a number line, if I were shading, right, doesn't really matter what numbers I have here, but the graph for it would look something like this, where you shade the entire number line, and there aren't any endpoints marked. Alright, so there's all the numbers in the real number system. Let's try another one. So here's my part B, so I draw my little river, so I know that I can't cross it yet. I have a set of parentheses, so I need to distribute there to those parentheses. So 2 times 2x is 4x, and 2 times -3 is -6. Alright, so then we want to get all of our x's to the left side. So I'm going to subtract 4x from each side. Here we cancel, leaving us with -5 is less than -6. And now we need to check out that inequality. Okay, so again, the x's went away, so it doesn't matter what value I'm choosing for x. Okay, I could choose 14, I could choose 37, I could choose 1/4. I could pick whatever I want for x. It doesn't matter, it'll end me up here with this inequality, and we have to ask ourselves if that's true. Now, negative numbers, they feel a little confusing to kids sometimes. So let's look at it on a number line. So -6 is right here, and -5 is right here. So because -5 is further to the right, -5 is bigger than -6. But here our inequality is saying that it's less than. So this isn't true, this is false. So what that means is that there are no real solutions. Alright, so in terms of the graph, what we do is we don't put any points or any shading on the number line. We just leave it as just a blank number line, as you see there. Okay, so now let's look at the try it. So here's my river. I'm going to distribute across my parentheses because we need to get rid of our parentheses. So I get negative 2 times 4x is negative 8x. And negative 2 times negative 2 is a positive 4. Okay, so I now want to move all my x's to the right hand side, or sorry, the left hand side of my inequality. So I'm going to add 8x to each side. Okay, so that leaves me with 4 is less than 4. Is that true? Can a number be less than itself? Now if it said less than or equal to, that would totally be fine. But just saying it's less than itself, that's not true. So this is not true. And that's all because there's not that little bar here underneath the inequality symbol. So there are no real solutions. Notice that it doesn't tell me to graph, so I don't worry about graphing it. Alrighty, let's try letter B. So again, on this problem, we have a set of parentheses. We're going to distribute to those parentheses. So negative 3 times 2x is negative 6x. And negative 3 times 1 is negative 3. So now to move my 6x over, it's already being subtracted. So I'm going to add 6x to each side. And I get that negative 5 is less than negative 3. Is this true? Well, yeah, like negative 5, right, on a number line is to the left of negative 3 on a number line. Therefore, yeah, that's a true statement. So that means that there are infinitely many, oh, my pen's being finicky, I'm sorry guys, infinitely many solutions. And there we have it. That is example number 3. Until next time.